First of all, there are various fundamental concepts in thermal physics that directly govern how modern kitchen tools operate. Chief among these principles are thermal equilibrium, the heat transfer equation, Q equal mc, delta T, the importance of low specific heat capacity in metals, and the role of the latent heat of fusion during phase changes. Understanding these major concepts is highly relevant in real-life food preparation scenarios, particularly when analyzing the efficiency of a battery-heated ice cream scooper, the version engineered without an internal liquid mechanism. Now we go through the component of needs. First of all, there is a core physical deficit address. What are the needs of this product? Okay, first of all, what specific thermal limitation or physical challenge does the tool resolve? First of all, it resolves high resistance to structural shearing in raw hardly frozen dessert, inefficient ambient heat transfer when using standard non-heated utensils, and messy, unsanitary, and temporary solution like dipping tool blades into warm water baths. And the last thing, the total reliance on internal conductive liquids in traditional scoopers, which eventually degrade, leak, or fail to maintain adequate temperature. And for the second part, whose operational changes are being targeted? We targeted a commercial ice cream parlors and high-volume dessert vendors. And we targeted professional pastry chef and culinary kitchen staff. And we targeted everyday consumers and families seeking effortless home dessert preparation.
Assalamualaikum warahmatullahi wabarakatuh. Here you with me Akif, where I will explain subtopic 2, situational context and frequency. When and how frequently do users encounter these thermal challenges? Every time ice cream is served straight from Sub-Zero commercial or residential freezer without thawing time. Next, during a high-intensity food service rushes where speed, portion control, and presentation consistency are mandatory. Last but not least, particularly when handling dense, low overrun like highly compact premium ice cream that resists manual scooping. Next, I want to explain about subtopic 3, impact, magnitude, and consequences of inaction. How is this problem for users, and what happens if it remains unresolved? First, repetitive strain injuries, wrist fatigue, and physical exertion for workers dealing with frozen solid daily. Also, a broken or bent plastic and metal utensil due to excessive mechanical force. Also, the service time is slow, poor presentation like shatter unappealing chunks instead of smooth spherical scoops, and customer dissatisfaction. Lastly, if left unaddressed, businesses suffer from decreased operational efficiency, higher labor fatigue, and missed opportunities to utilize modern liquid-free thermal technology. That's all from me. Thank you.
Component of approach. Subtopic 1, technical system functionality. What is your unique engineering approach to meet this need? First thing first, an internal electronic heating element powered by a compact rechargeable battery cell embedded in the handle. Second, a liquid-free solid metal scoop head designed to directly conduct heat without relying on hazardous or leaky chemical fluids. And the next one are, what is your solution broadly? It is a thermal active self-heating scooping utensil that generates autonomous thermal energy. Then immediate localized melting at the contact boundary using highly conductive, low mass structural metals.
What specific physics principle and mechanism are applied in this system? Low specific heat capacity. The scooper head is manufactured from advanced alloy that require minimal heat energy to experience a drastic rapid increase in temperature. 2. Accelerated heat transfer. Electrical energy from the battery is converted to thermal energy, creating a high temperature differential between the hot metal and the sub-zero dessert. This maximizes the rate of heat flow. Phase change via latent heat of fusion. The high thermal energy directly supplies the latent heat of fusion required to instantly transition the stubborn solid ice cream into a thin lubricated liquid layer upon contact.
Okay, so hi guys. For my part, I will explain to you guys about the observable physical outcomes from our product. So, what are the practical benefits and observable effects of this system? First of all, we have rapid thermal equilibrium. The scooper head continuously replenishes lost heat, maintaining a consistently high temperature even when battling large volume of freezing ice cream. Second of all, minimize mechanical resistance. Because the boundary layer of the ice cream melts instantly, the friction drops to near zero, allowing the tool to glide through dense solid without requiring physical restraint. Third, optimize energy efficiency. By directly heating only the metal surface in contact with the desserts, zero energy is wasted heating up unnecessary liquid, and no hot water baths are required. And lastly, preserve food presentation and integrity. We can prevent the ice cream from fracturing into ugly, shattered chunks, resulting in perfectly formed, smooth, spherical scoop every single time. That's all from me. Thank you.